Let's get started again. And we'll just welcome everyone else back when they get back. I want to make sure we stay on time, if that's okay. Okay, guys? Okay, let's get started. So the next topic is fast application switching and tombstoning, which is kind of an interesting name for a feature in Windows Phone. And actually, it's not on the title, but we're also going to talk about multitasking in this session. All right, so we'll talk about a couple of things. We'll talk about the execution model of how, the state model for how the life cycle of an application works. It's kind of important that you understand it because it's going to make a difference in how your application performs when the end user hits the start button and then comes back. It's really critical. We'll talk about fast application switching and how you support that, the difference between dormant applications and tombstone applications, and then we'll talk about navigation and application switching. And then, like I said, we're going to move into the next topic, which is multitasking. So before I do that, I think the easiest thing is to actually show you fast app switching. And I think I lost my device. I did lose my device. Okay, well, what's that? Let's just use the emulator. And so you see what I'm doing there is I'm starting some apps, and then I'm hitting the start button. And let's just do one more. Right, so now I've done it 3 or 4 times, and you'll see that what happens when and this is the problem I hit last time. There's no way to force fast app switching on me, so I actually do absolutely need my device. What did I do with it? I hope I didn't lose that. That was kind of... Uh-oh. This could be a problem.
You could use the My Windows Phone feature.
The My Windows Phone? Yeah. Did you see that?
Try to ring it?
No. I don't know what I did with it.
You can use the service.
The
Yeah.
service? What service is that?
Which makes it ring. Yeah.
What's that?
Loud.
Which you told us about.
Yeah, but it's
Practice makes perfect.
wow. I think I lost my device. Pardon? No, it doesn't have a SIM card. It has a SIM card, but not a voice plan. It has data plan only. Okay, well, we're not going to see how fast application switching works, but I think I showed you earlier. Basically, what you do is you you tap and hold on the back button, and when you do that, it will basically give you a panel that allows you to see the last 4 or 5 applications that are running. And it depends on how much memory you have in your device and how much memory your applications are taking. That will depend on how many applications you'll actually see in that list. And so typically you'll see about 5. So the question is, how does that work and what's going on behind the scenes? And so that's where it's kind of important that you understand the life cycle of an application. And there's really 2 different ways to look at this. One is where the applications that are in the background are dormant or sleeping. But dormant is the word we use. And the other one is tombstone, which means they've been basically thrown out of memory and they're on disk and you have to reload pretty much from scratch. So let's look at the dormant scenario. So we always start from a running state. As you can imagine, your application is running, and then the end user does that crazy thing of hitting the start button. And so as soon as they do that, you immediately get a deactivated event. And that means that you need to do something because you have just a couple of seconds to save your state before you're basically turned off. And so you get a chance with the deactivated event to save your state. And then at that point, you become dormant. What does dormant mean? That means you're still in memory, but you're not taking up any threads. You don't have access to CPU. You don't have access to GPS. You don't have access to, you're basically not running. Everything is turned off. And so you're idle. You're waiting. And you're sleeping. And then at some point, the end user, either by hitting the back button or by using fast app switching panels, will switch back. Oh, and of course, all of the resources are turned off. Threads, timers, everything's suspended. So at some point, the end user hits the back button, and you now get another event, which is the activated event. And at this point, you need to know, was I dormant or was I tombstone? And we'll talk about what the differences are in a few minutes. But the way you check that is by checking one variable. You look at your is application instance preserved. If it is preserved, that means that I was dormant, and so everything is still in memory, and so I can just continue on running. Basically, I can turn, my threads get turned back on, my timers get turned back on. I need to go and reattach resources. So for instance, if I had a socket connection out to a server somewhere, I need to go and connect that up again manually. I have to do that myself. If I was playing a video, I need to reload the video and set myself at the right spot in the video so that I can continue playing. So all of that stuff needs to happen, but the important piece is that your app is still in memory, and so all of that should just be very quick, right? It should just happen, and then you're back to the running state. So the interesting part is, and then, so that's what we refer to as a fast app resume. So what happens when we're tombstone? Similar scenario. I'm running, I hit the start button, I'm deactivated, I save my state, I'm now dormant, but this time the end user has done that 4, 5, 6, 7 times, whatever it takes, depending on how big those applications are. If you're doing that with games, if you have 2 or 3 games, it's not going to take very long for you to run out of memory on the device, and then the operating system is going to say, you're running out of memory, I got to get rid of something from memory, and that's when your application then gets tombstone. So the oldest app in the stack is going to get tombstone, and that's by how long the app, the usage of the app was. That gets tombstoned. And then you go through a similar scenario, right? So I'm tombstoned. In other words, not only do all my resources get turned off, but I also lose my access to memory. So I'm actually thrown out of memory. And so now when the end user hits this, the back button to come back to it, I get the same activated event. This time, again, I have to check, is my application instance preserved? It isn't, that's false. And so now I have to go and reload all of my memory. All of the state that I saved when I got deactivated and saved it to disk, I now have to reload it. Now, of course, there's a penalty for that. It takes a little bit of time. And so typically, you'll see a resuming screen. You'll see resuming with a few dots going across the screen. And depending on how much state you have and how long it takes for your application to load and how long for memory to get reallocated and all that good stuff, it could take a while. For games, it could take seconds, tens of seconds, depending on how big the game is. So you want to try and avoid that. You want to try as fast as possible. And then at some point, you come back to running. And this is where you see the resuming screen. Any questions on this?
Yeah.
Sure.
But let's say you have your games, but say, okay, our game will always be dormant state, and then it goes into tombstone state.
So the question is it possible for me to get a special status
Yeah.
and make my apps never go tombstone? No. Nice try, but no. No. If you think about it, how would we decide who gets to be dormant, who gets to be tombstone? So every app goes through the exact same life cycle. Doesn't matter who you are, whether you're an Xbox Live app or even Outlook, or we basically treat every app more or less the same. Yes?
Is there any way to handle special cases like a music player that plays in the background or GPS tracking in the background or similar cases?
Yeah, so the question was, well, what about some special cases where I absolutely have to continue running in the background? One scenario might be a music player, right? If I'm listening to music, I need to continue listening to music. Just because I hit the start button to go and check my email doesn't mean my music should stop, no matter what. And there are specific scenarios. Music is a special one, and it does have a special way of doing that. There's But that's not fast app switching, that's multitasking. There's a difference between multitasking and fast app switching. And so we're going to get to that in a few minutes. There's a few different scenarios. One is background audio, the other one is file transfers, where you want file transfers to continue in the background while you exit your app. So yeah. I think I saw a few other hands. Did I answer your questions?
This
Yes.
deactivate state, how long time do you have to?
Yeah, you have about, I think it's about 10 seconds.
You have 10 seconds, all
Yeah,
right.
not a lot of time.
That's,
For most people, it's plenty, but it depends on how much memory you have and what you're doing. And it's not enough to go and save stuff out to the cloud and all of that stuff. You save stuff to isolated storage and get out of memory, because you don't know what's going to happen. You have to assume that you're going to be tombstoned. Even if you don't, you have to make sure that everything you do in the deactivated state, if you get tombstoned, you can basically reactivate. Questions? Is this confusing? Does this make sense? This is directly out of the msdn.com page, so don't feel like you have to copy it down. You can just go to it. Anybody remember what that page was? Create.msdn.com? Yeah, okay. So this is actually a really nice diagram that shows not just the states, but which events and which methods you can override to hook into those states. So you have the application launching event, and then the on-navigated to method, and then you're running, right? So when your application launches, you always get the launching event, and then you get your on-navigated to for the page, right? So you have an application launching and a page on-navigated to. So if you have multiple pages, each one of them gets their own on-navigated to event, right? Then you're running, and then when you get, when the user hits the start button, then you get the on-navigated from, as well as the deactivated event. And so you can take advantage of that. Then you're dormant, and depending on where you're coming from, you then get the activated event and the on-navigated to method. You're back to running, and then at some point when the end user exits the application, you will get the on-navigated from method on the page and the application closing event. Again, this is, don't try and write this down. It's right in the specs and the docs, so you don't have to write it. But it is important that you understand all of these, because you'll take advantage of all these. And in fact, we're going to see some of these in a couple seconds. So finding the resume type is kind of important, as you can imagine. As you go through these various states, you want to make sure that if you're dormant, you're not reloading stuff because you don't have to, right? Because you're already there. Just take advantage and start partying right away instead of trying to reload stuff. And so it's pretty easy. You get your application activated event, and see, here's my activated event arguments. And then as part of that, I would just say if is application instance preserved. If it's true, that means I was dormant, and so my objects are in memory and they're intact. I don't have to do much. I still have to reattach resources and so on. But if I'm tombstoned, then I need to reload from isolated storage. The other thing that's important is that there's resource management that's related to this, right? And so as you go through the different steps from a deactivated app, you have your on-navigated from, then you're deactivated, and there's certain things that need to happen as part of that. And so things like media player, you want to pause it. Media element, you want to pause it. If you're in sound effect instance, if you're in vibrate controller, all of these things, you want to control that so that you know that you can re-enable that. You're basically going to save the state, save the page as well as the global state, and then you're done. And then the framework is going to detach resources. You don't have control over that because it's going to get rid of all of those attachments. This is not an all-inclusive list. There's all sorts of other things that don't get done, but you do have to take care of that. Things like XNA audio, sensors, networking, sockets, media element, the camera, all of that stuff, so that when you come back, you have to remember to reload that stuff. And then at some point, after all those resources are detached, then your timers and threads are suspended, and then you're sort of, you're stuck, right? You're waiting for the end user to hit the back button. And then activation kind of happens in the other direction, right? So now from a dormant app, the framework is going to resume your timers and threads. It's going to attach some of the resources, and then activated on navigated to. And at some point, you have to go back and do things like reconnect your socket or new up a new photo or new camera object, your media element, you want to set your source and skip to the position where you were when you exited, right? So all of those things need to happen. It's really quiet here. Are you guys getting this? Is this making sense? Okay. So there's two different kinds of storage. There's isolated storage and there's state storage. You should take advantage of both. Isolated storage, as it sounds, is actually saving to the equivalent of disk, so it's a little bit slower, but it's permanent and it's there when your app launches. It will always be there as long as you leave it there. But it's slow, right? It's using NVRAM technology, so think of it as disk versus staying in memory. And then state storage, as you can imagine, is storing state, but you're storing it in memory so that if your app gets tombstoned, it's not there anymore, right? So you need to, when you're dormant, you can grab your state from your state storage. When you're tombstoned, you got to grab it from isolated storage. And so let's look at a couple of examples. Starting to lose my voice a little bit. So is this still boring? Are you guys?
Question?
Yes. Let me just load my Visual Studio project and then we'll take some questions. That one. Okay. We just run it, and then are there questions? Yes?
Yeah. So you're using the application, you save some parameters in the memory, some settings in the memory, and then you exit the application. Who's going to clean the memory?
Who's going to what?
Clean the memory. Is the garbage collector who
Yeah.
takes care of that? Or?
Yeah. Yeah, so the question was, who's going to clean up my memory? And it's the GC will take care of it, yeah. I mean, you can do it yourself, but I think GC will just do it.
Yeah.
Any other questions? Okay. Yeah.
Is there a way to tell DC that it's okay to do it now?
So there is ways to control the GC. Most people don't. You just don't. Unless you're doing stuff like gaming, for instance. I think Ian, are you here? Ian Kvist will talk, hopefully we'll talk about some of that when he talks about XNA. Because gaming is kind of important because you don't want the GC to kick in, the garbage collector to kick in the middle of you're just about to hit your opponent and then suddenly your game skips, or it's just not a good experience. And so you want to control the garbage collector. In fact, for the most part, you want to eliminate the garbage collector if you can. Can't always, but in many cases you can. Any other questions? So I'm going to go through 3 different examples, and each example is increasing in complexity in what the example does. It's a very simple example, the same level of what we saw earlier, the adding machine. It's a captain's log, so for those Star Trek fans. So here's my application. It doesn't really do much. Oh, let me get rid of my SIP. So test 1. I'm going to store that. And so if I view my log now, I should have one test, and there's a time and date and the text of what I typed in that entry box. Pretty exciting stuff. So what happens now if I hit the start button? Anyone want to guess what happens if I hit the back? The app was dormant, right? And so if I hit the back button, nothing happens, right? The app is still there. And so if I hit back and view log, everything is still there because it's in memory, right? So I didn't have to worry about it. On the other hand, if I exit the app, whoops, I guess I've stacked a bunch of apps now. That's fast app switching, that's what it's for. So now if I come back to it, anyone want to guess what happens when view log? Nothing, right? Because in this case, nothing is being stored. So let's have a look at what's going on behind the scenes. And it's actually a pretty trivial application. So let's look at the main page. Wow, this is a really big font. But, so the main page doesn't do a whole lot. It's basically grabbing that text out of the text control, and putting it into a global variable, right? And then at some point, you also have the ability to get to the log page by hitting the view log page, right? Pretty straightforward stuff. And the log page doesn't do anything either. It's basically just grabbing that global variable and putting it to the screen, right? Just displaying that on the display. Nothing fancy going on there. All of the hard work is happening in the app.xaml file. The app.xaml file is, as you can imagine, the XAML file related to the application. So this is where stuff happens that's global to your entire application. So anything I do here will happen in a number of different areas. And so let's have a look at some of the things. I'm going to skip over some of these things, but you'll see here there's a global variable called log text, and this is where my edit control is storing stuff, and there's a log entry. And then you see some of these events that we saw earlier, right? There's an application launching event, which is blank, it's not doing anything. Application activated event, it's not doing anything. Application deactivated, it's not doing anything. And so as you can imagine, if I store stuff in memory and I exit, not having done anything with it, when I relaunch the app, it's gone, right? So let's see what happens if we take it a little further and add some storage. And so take my word for it, log page and main page, those are pretty much done. They're pretty much the same as before. So if we go back to AppXAML now, and if I scroll down, you'll see that there is some interesting stuff going on. So here's my application launching event. So when the application launches now, it's going to check my isolated storage to see if I saved anything. It's going to load it. And there's a helper method to do that. And more importantly, when I'm closing the application, I'm saving to isolated storage. Anybody notice what's missing? Activated and deactivated, I'm not doing anything, right? And so let's see what happens when we run this, because it's kind of important that we understand this now. So here's my application. It's going to look identical. It's called the same thing. And so let's just make sure there's nothing there, right? So now let me add something to the log. Let me store that and view it. It's there, right? So if I hit the start button and exit, no difference, right? So it's still there. Great. Now if I exit and restart it, anyone want to guess what's in the view log? Should still be there, right? And there it is. Now, the problem is that I want to test for tombstoning, right? So we already know the dormant is working. How do we test for tombstoning? The problem is that tombstoning requires you to run out of memory. And it's pretty hard to do that on a PC. And so there is the capability to actually force that. So let me exit out. And come to my project, right? So I'm clicking on the project, Captain's Log. I don't know if you guys can see it in the back. Right-click and go to Properties. And you'll see that there's a Debug tab there. And there's a tombstone upon deactivation while debugging. So what that means is as long as the debugger is active, anytime the user hits the Start button, if my application gets deactivated, it's going to get tombstoned automatically. And so this allows you to test both scenarios very easily without having to load lots of stuff in memory and hope that your stuff gets tombstoned. And you don't know when it gets tombstoned. It's just really hard to do otherwise. So I'm going to check that. And we'll probably have to come back to it and run it a couple times because we're going to do a couple of different scenarios. And so now if I view my log as before, it's still there because it was in isolated storage, right? Let me just add one more here, test 3. Store, view log. So that still works. Now, if I hit the start button, anyone know what's going to happen? So it gets tombstoned, right? So what happens when I come back? What's going to be in that page?
Page 2, it says 2.
Does anyone see what happened there?
Yeah, we're not loading it.
Anyone know why that is?
Yeah, we're not loading it. We're only saving upon
Exactly. I'm only saving upon exit. So even though, if you remember back, I still have that test2 that test2 entry is actually there. Let me just exit and show you. And if I view log, oh, it's not there. Did I not save it? Oh,
Yeah,
okay.
you exited the application.
I exited before I saved it, didn't I? Oh yeah, okay, let's try this again. S2, store, view, it's there. You exit out, captain's log should be, okay. When I exit, I lose my debugger, so I need to run it again from there. View log, it's still there, right? And so now if I type test3, store, view log, okay, it's there. Exit. You notice I exited, but the debugger is still attached. I don't know if you guys can see that. And that's how you basically are testing for the tombstoning scenario, because you need to be able to test that when you come back. So there, and now view log, it's still not there. Wow. Wow.
Because
Okay.
you're exiting the application and you're storing your data on exit, and after the tombstone install.
Oh, you're right, I exit again and I'm
Have any,
overriding. Yeah, thank
save.
you, okay, thank you. So I'm losing my mind. So the gentleman correctly pointed out that I exit out, and when I exit out, because I have no log entries, I'm actually saving to my isolated store a blank and basically overriding my test2, right? So this is kind of behaving well on my exit and launch, but not so good when I'm tombstoning. So let's have a look at what happens when we tombstone, sorry, when we handle it properly. Okay, so let's have a look at the code before we run it. It's a really big font. So here's my launching. I'm loading from isolated storage, but now I'm checking my application activated. So here it's checking, is the application instance preserved? In other words, if I'm dormant, if I'm not dormant, in other words, if I was tombstoned, then I want to load from state object. And then if I was deactivated, yeah, that makes sense. And then when I'm deactivated, I'm saving both to isolated storage and to the state object. So I'm basically taking care of the scenario where I'm exiting the application, so nothing's in memory, versus saving to the state object. And then the application closing is the same. So let's see how that runs. And I should double check that I have my debug set. It's not. Okay, let's try that again. Okay, so my log should be empty, and it is. So now I'm going to write my test4 here. I'm going to store it. View my log. That's great. If I exit and come back, view my log, it's still there, right? Because there, in this case, it's loading from isolated storage. Now I need to rerun it to trigger, otherwise I wouldn't catch that tombstoning event. Just make sure I have my log entries are there. Let me add one more and store that. Now I'm going to hit the start button. I've now gone through the deactivated where it's stored to state and isolated storage. It got tombstoned. Now when I come back and view the log, I get both. And if I exit and come back, I still have both. Right? So this is what you'll have to keep track of when you're doing. And I can tell you that tombstoning and fast app switching is an important topic. It's important because your end users will expect your application to behave properly, just like Windows Phone first-party applications. The Microsoft applications handle this properly. Your application should try and do the same, so that otherwise you're going to be losing data, or in some cases you may be restarting pages in the wrong space, and so it gets very confusing to the end user. And so again, if you don't handle it properly, it leads to poor ratings and sometimes to end users just uninstalling your app. Any questions? Yes?
I'm just curious, the isolated storage and the state storage, what kind of storage mechanism are you using?
Yeah, so we can look at, yeah, it's the standard stuff. It's what you would expect from Silverlight. Whoops, I passed it. So here's the data, and here's the saved to isolated storage. And load from isolated storage, save to state object. It's pretty straightforward stuff. And then, so isolated storage, here's the actual code that saves text to isolated store. Right? It's kind of hard to read here because it's a huge font. But basically, you new up an isolated storage settings object. In this case, we remove it basically to clean it out. So you always start with a blank, and then you add it back, and then you hit save, and you're done.
So this is, do you have an actual file system, hierarchical file system, or is it just
There
a key
is
value store?
no. In this case, actually, it is a key value store, but you can do it as a file system. You can. In this case, it's using key value pair because it's using it's hard to see on the screen here. We're using application settings, which is a special condition where it's actually using a special file name and you're storing it. It's just a convenient way of putting stuff, key value pairs, into isolated storage. But if you want, you can actually define your own file and do all of the standard stuff that you would expect from file stream. Any other questions? Yes?
Do you have access to the whole memory from a developer? Because a normal user don't have access to the file system on the phone. But do you have it from your application?
So the question was, do I have access to the whole memory? And
The file system.
you have access to your own sandbox. So when your application gets installed, you can create a isolated store file, and that file can be as big as the space on the device. So if I have a device that has 18 or 16 gigabytes, I can fill that up if I want.
But
of
you
course,
cannot have two
what's going to happen is the end user is
applications
going to hit
that can share.
uninstall, right? Sorry?
You cannot have two applications that can share a single file.
Good question. So the question is, can I have two applications that are both sharing the same isolated store? The answer is absolutely not. Every application is isolated from every other application for security and stability reasons. So you never have access to any other sandbox. That's the whole point of a sandbox.
What about updating your application? Will the isolated storage from the old version be preserved to the new version?
So the question was, well, what happens when the end user, when I update my application and the end user takes the update from Marketplace?
Yeah.
Will that wipe out my isolated store? And absolutely not. It's preserved. Now, of course, it's up to you to make sure that you read it and write it in the same way. So if you've changed your structure, you'll have to, create a new file, and rewrite it and so on. But yeah. I should mention, we're not going to cover it today, but there is also a SQL database on the device as well. There's just not enough time to cover it today. I think there's a question in the corner. Oh, okay. Okay, yeah, there is a SQL database on the device. Yeah. Any other questions? Okay. How are we doing? So I think that's it on fast app switching, right? Let me just. Yeah. So just to review, there's only one Windows Phone application that is active at any one time. And as a result, I've said this a few times, we're trying to optimize for the experience of the end user. And so that means that we always try and make sure that the end user's experience is optimal. And the way that you take away from that would be if stuff was running in the background that you had no control over, so that the end user had no idea why their application is running slow. There is nothing running in the background. We're going to talk, there are some scenarios where there are, we're going to talk about it in a few minutes, but when we're talking about most cases, applications are single pass, right? You have one application that's active at any one time. The start and back button, we talked about that and how easy it is. We talked about when an application is dormant, it's still in memory, but it has access to no resources. And then when it's tombstoned, it's actually removed from memory. And then you take advantage of the app.xaml.cs, which is the code behind for the app, to save and retrieve state when appropriate, either when your application is starting or closing, or when it's activated or deactivated, tombstoned or dormant. Any questions? We're going to move on from tombstoning. It's a really important topic. It's important that your application handle it properly. So if you do have questions, please let me know. Okay, so that was the case where you have one application running at any one time. And yet, as the gentleman mentioned earlier, there are scenarios where some things need to run in the background. And some of those scenarios we're going to talk about. There are some generic scenarios where we don't know what might be happening, and we refer to those as background agents. There's two different types of background agents, a periodic and resource intensive. I'll talk about what those are in a couple seconds. There's also a background transfer service, which is essentially a hardened service that we have in the operating system, in the platform, to actually download files or upload files for you in the background. So basically, and we'll talk about how this works. Basically, you hand the operating system a file to download, you tell it where to put it, and then even if the end user exits your application, it continues going in the background, and then you can either monitor progress or check status and so on. We'll see how that works in a couple seconds. There's also the case of alarms and reminders. This is kind of, pardon me, I'm losing my voice, and now I'm spinning also. Another case is alarms and reminders. This is sort of background tasks. Essentially, it's, as you can imagine, an alarm is just like an alarm clock. You set it, and it goes off at a certain time. And a reminder is sort of like a calendar reminder, where it goes off at a certain time, but there's some additional information related to it. And we'll talk about how that works in a couple minutes. And then the final one is background audio. This is a very, what you think of when you think of background tasks. And yet, very few people are actually doing background audio, but when you're doing it, you absolutely need it to work in the background. And so we handle that. We're not going to actually get into the code today, but how many people are actually doing audio type applications? Yeah, there's only a few, 2 or 3. So it's very well documented. There's actually a template, as we saw earlier. There's actually a template for background audio in the application. Anyway, we'll get to it in a few minutes. So let's talk about background agents. So background agents are kind of generic. There's 2 of them. One is called periodic, and the other is called resource intensive. You can have up to 1 of each. So your application can run in the foreground, as well as have background agents. It's up to you. And those are initialized in your foreground app. So an end user actually has to run a foreground app, and in that foreground app, that's what you use to launch your background agents. And those are persisted across reboots. So if you start your background agents, and the end user restarts the device, your background agents will get restarted across a reboot cycle. The user always has control. Again, I've said this a few times, we're optimizing for user experience. And so if you have a background agent that is misbehaving, the end user has the ability to just say, sorry, you no longer have the ability to run in the background, and they can turn off. And I'll show you where they do that. There's actually a control panel in the settings. Agents run for up to 14 days, but they can be renewed. And basically what you do is every time you run your app in the foreground, you renew your background agents. And so if your end user doesn't run your app for 2 weeks, your background agent will get disabled until they run it again. So if you think through the scenario there, the idea there is to prevent the end user having lots and lots of background agents that they don't care about anymore. Sort of the prototypical, I hate to use the word, but crapware, where you download, install an app, and you forget about it, but it's still running in the background taking up resources, using up the memory, using up battery, using up CPU, and yet the end user doesn't care about it. And so over time, if the end user doesn't care about it, they don't run it for 2 weeks, then it will actually automatically disappear. Make sense? There are two different kinds of scenarios. There's the periodic agent and the resource-intensive agent. The periodic agent basically occurs every 30 minutes on average. It's not every 30 minutes exactly. It might be 27, it might be 33, it might be 40. It varies, right? But on average, it's going to be about every 30 minutes. And you get about 15 seconds to do whatever it is you need to do within limits. There's certain things that you cannot do, and we'll talk about that in a few minutes, within certain constraints. So your background agent cannot take more than 6 meg of memory, and it can never run or take more than 10% of the CPU. And the operating system will control for that and turn you off if you try to go beyond that. So again, the periodic agent, every 30 minutes around the clock. It's just going to keep going every 30 minutes over and over and over again. And it's up to you to decide what to do with those 15 seconds every 30 minutes. The other one is referred to as resource intensive, and that occurs when two parameters are set, or two things happen, in other words. So first is the device is actually plugged into power, external power, and the device is on a non-cell network. Anyone think of what the scenario is there? When you get home, right? You get home and you put your device on your bedside, you plug it into power, you're at home, so you probably have Wi-Fi at home, so you don't have to worry about how much data you're going to pull down. You don't have to worry about power because you're plugged into power. And so when you do that, you pretty much can do anything you want for 10 minutes. That's a lot of time for an application to do that. So that's where you do power downloads, right? So if you have, I don't know, an RSS reader or something, you might want to actually go and re-pull all of your data, because you can. And you want to refresh everything and make sure everything's there for the end user when they get up in the morning and unplug, they have fresh data, right? And so that's 10 minutes to do, have a party, go to town. 10 minutes is a lot of time. You still have the same constraints, 6 meg of memory, but you don't have to worry about the CPU because the assumption is that it's idle, right? You're plugged into external power, you're using a cell network, so it takes less battery and so on, so you don't have to worry about that 10%, although it will back off if the end user actually starts using the device while it's on power. It will actually back off and you don't have access to it.
In what ways will it back off?
You will just lose access. Your agent will get turned off. So there are certain things you can do and certain things you cannot do. Things like updating the tiles. Remember we talked about live tiles? We're going to talk a lot more about live tiles in a few minutes. Popping up a toast on the screen, which is a very intrusive thing to do, but sometimes important. And we're actually going to see that in a few minutes. You can use location and check the GPS or location on the device. You can go to the network and pull stuff down, right? Do a web service call or what have you. You can read and write from isolated storage. You can open up a socket connection. And you can get access to pretty much most of the framework APIs, except you can't do anything to display. You just can't write to the UI. Background agent is what it says. It's an agent that's running in the background. That means you're not in the foreground. It means you don't have access to the UI. XNA libraries you don't have access to. The microphone and the camera is debatable whether we should have done that or not. We decided for privacy reasons that it doesn't make sense that stuff in the background is recording sound and taking pictures. It's a little iffy, right? And so we've decided that you cannot do that. You just won't get access to it. A lot of the sensors you want to have access to, and you can't play audio. You can't play audio using the background agents. Don't forget, we have background audio, which is a separate service that you can take advantage of to play audio in the background. Any questions there? It's pretty straightforward. So what's that?
I have a question.
Oh, yes, sorry.
What about when does it occur? Is it when you plug it in, or do you have can you time it to different?
So the question was, when does it occur? Can you time it, or does it happen when you plug in? And it happens when you plug in.
So
When you plug in, and you're on non-cell, and the device is idle.
So you won't get the early morning news feed.
That's true. So the response there is you won't get the early morning news feed. So you get it At the end of the day, you plug in, but maybe 12 hours later, you might get new data overnight. You won't get that. Right. Yes?
You have this 10-minute time slot. What if other applications have the same?
Serial. You would just get one after another. So the question was, well, what if I have 2 applications or 10 applications that all have resource-intensive background tasks? You'll run serially, and each one of you will get 10 minutes. Yes?
If you don't use Wi-Fi and you let put a setting on the device, so it will also go on with the normal cell network?
So the question was, what if I want to do resource-intensive data transfer on a cell network? Not possible. It's not possible. There's 2 scenarios. It's non-cell network, and that can mean 2 different ways of getting data on the phone. One is Wi-Fi, and the other one is you've actually plugged your device into a PC where you're actually using the network of the PC. You can't use the cell network. If you're on a cell network, your resource-intensive task will not launch, will not get triggered. Sorry. Time to get a Wi-Fi at home. I'm kidding. Anyone else? Yes?
So when I have my phone on and I unlock it, it starts looking at the Wi-Fi networks and it locks on my network at home.
Yes.
But if the phone is locked when I plug it in, then it's not connected to the Wi-Fi.
Yes, it should. It should. So the question was, well, what happens when my phone is locked, and so it's not connecting to Wi-Fi? And in fact, it should. Even though your phone is locked, you should still be connected to Wi-Fi.
But you see, every time you unlock the display, you see it starts looking at Wi-Fi and then
It's popping up a screen that says Wi-Fi is available. But if you're already connected, you'll be connected. Think about it, right? It's still downloading your email. It's still doing your, all of that stuff is still happening in the background.
No.
Should be. Yeah, should be. Okay. You're going to fight me, right?
Yeah.
All right, well, meet me outside later.
Yeah, all right.
If you want to check it, let me know. It should actually be
When you see
connected.
the icon in the top, it's looking at the Wi-Fi. And
That
then
means you're not connected.
And then it's disconnected after a couple of seconds after you have unlocked the phone.
It shouldn't. You should be connected in the background. Yeah. And if you think about it, Wi-Fi is much less expensive from a battery perspective than cell networks. It's very expensive. There's 2 things that are really expensive for the battery on the device. The first one is the radio, the cell radio, and the second one is the screen. And so wherever possible, you want to get off cell network and onto Wi-Fi. And of course, it's actually more expensive for the end user to use, you have a data cap. So whenever possible, we should be connecting to your Wi-Fi network. Any other comments, questions? Anyone? Okay, so I have a demo. Let's actually load it up. This is very similar to my captain's log from earlier, except now you'll see that the project file, the solution is actually quite different. And again, I apologize for those of you in the back of the room. You will see that there's actually 1 solution, but 2 projects. There's a captain's log, which is my primary foreground application, and then there's my location task agent, which is my periodic agent, right? And so when I launch my foreground app, anyone know where I might want to fire it off? In the app.xaml, right? Whenever it launches and activates, you want to make sure that your background task gets triggered. And so you want to renew it every time you launch it, because otherwise, remember that 14-day period, you're going to lose it. So you don't want to rely on the end user having to press something to launch it. You just do it. So let's actually see how that happens. Find it now. Oh, okay, in this case, it's a little different, sorry. Let me just show you. We are actually using it. In this case, this is not the way you'd want to do it. In this case, we're actually relying on the end user to hit the start tracking button. And when you hit the start tracking button, it's going to launch that background. The problem with that is if the end user runs this application and doesn't hit start tracking, after 14 days, that background will just stop running, which is fine because this is kind of a goofy scenario anyway. But let's just, let's see what happens in that start tracking. So here is the code to launch that background service. And I apologize for the size of the font here. It's kind of hard to see everything at the same time. It's really just a few lines of code. So it's, you see up at the top, periodic task. Can you guys see that? So periodic task, this is my task that I want to start. I'm going to go and find it. To make sure it's in memory. And if it's null, that means it's not in memory. I want to start tracking. If it's not null, that means it's already running. If I hit that button, it's going to stop tracking. And so basically, that button is kind of a toggle, right? So if I hit it once, it's going to start tracking. If I hit it again, it's going to stop. You guys get that? And so that start tracking. Here's the start tracking. So here's where it actually does stuff. So it's going to find that periodic task. If it's not null and periodic task is enabled, if it's enabled, if it's not enabled, periodic task is not null and it's not enabled. Anyone know what that might mean? Thank you. Very good. Exactly. So the user has actually said, sorry, you don't get access to background agents. And I'll show you how the end user does that in a few minutes. But you can check if the end user has disabled that. There's no way, if the end user has enabled that, has disabled your background agents, there's no way for you to re-enable them. You can pop up a message and tell the end user, hey, background agent's not running. If you want to run them, go to the control panel and re-enable it. But otherwise, you have no control over that. Remember, what we're optimizing for is the end user experience. So anyway, so there's the message box that says, hey, background agents have been disabled. And now, yeah, so if it's running, we're going to basically stop it and rerun it. So here's a new periodic task. We're going to give it a description. And now here's some handy code. So here what we're checking for is if the debugger is enabled and attached. We're going to do something interesting. We're going to launch the task and give it a time span of 60 seconds. Right? Remember what I said? Periodic tasks run every 30 minutes, which is great for the end user, really hard for the tester if they have to wait 30 minutes between every run. And so what we're going to do, actually 60 seconds is kind of long, so I'm just going to say 15 seconds. And again, it's on average. It's going to depend on what's going on in the OS, but that's kind of what it's going to do. And then let's actually have a look at what's going on. So here's the location task agent. If I come to my task set scheduler, here it is here. And so, see if I can give myself some more room. There it is. Here's the onInvoke. So you're overriding an onInvoke method, and then basically you're doing some stuff, right? I'm checking what date and time it is. I'm going to take that as a string so that I can remember we're doing that timestamp. And then we're also going to do, in this case, we're going to actually locate the device. We're going to use the location service to find out where we are and write the latitude and longitude as a string into the log. Right, and then we're doing the same thing here for 15 seconds. Okay, so let's run this and see what it does. So let me look at my log. Remember, we still have those two entries. This was from the previous version. So I'm going to write it, I don't know, I forget what the numbers are. Let me just store that. So there's my thing still working. Now I'm going to hit start tracking. When I do that, it's now started that background transfer, sorry, that background agent, periodic agent. I'm going to exit the app. And now I'm kind of waiting. One of the things you may have noticed when I exit the app is that the app is actually still connected to the debugger. You can see in the top right-hand corner, you can still see the stop button. The reason is because you need to be able to debug tasks. And so I don't know if you saw that. You can see that one of the things it's doing is it's popping up toast. And I was going to click on it, but it was too slow. Let's wait for the next one. And here it comes, I think. There it is. If I click on it, toast allows me to deep link. And so that means I can actually click and get into my app directly from the toast. And so now if I look at my log, and there's my log that tells me those 2 entries that are going on. Pretty straightforward, right? Any questions? Yes?
What happens if you run out of time? Let's say you have a lot of, critical code running, and you run out of time. That could potentially lead the background task in inconsistent state. What happens to that?
Too bad. That's a bug. So, sorry, so the question was, hey, what happens if I run out of time? I have a certain amount of time every 30 minutes to do stuff. I think it's 10 seconds. 15 seconds? I can't remember now. Oh, 15. Okay. So I have 15 seconds and something ran slow. Maybe I'm doing a web service call and my server happens to be slow that day. Too bad. You will get cut off. The operating system will shut you down. You do not have the option to extend your stay. No visitors allowed after 15 seconds. And so that app has been running in the background. I think. Probably got, no, it hasn't. Ah, you're right. You're right. I'm only, thank you. Someone's paying attention. So I'm only loading states and oh, you're right. When I exited, I overrode it with what I had. So anyway, clearly a bug in my code. Thank you. But yeah, so it's continuing to run there, and if I exit, it will continue to update the log. Yes?
These background agents have to take care of Tombstoning?
Do the background agents have to take care of Tombstoning?
Will they ever be Tombstoning?
No. So the question is, will they be tombstoned? No, because they're running in the background. And the operating system is taking care of the processes and all of that good stuff. So, yeah. That by definition, multitasking is multitasking. It has to be able to run. Yes?
Background agents restarted when we restarted before?
Say that again?
Are the background agents restarted when we restarted before?
Good question. So the question was, will background agents get restarted when the phone gets restarted? And the answer is yes. They will continue to keep going for 14 days, up to 14 days, unless you renew it. Yes?
And background agent read SMS stored on or arrive as they arrive in the phone.
So the question was, can the background agent, and actually let me extend that, can anything read SMS as it comes in? The answer is no, there's no API for that. You don't have access to the SMS stream.
Not even for sending.
Not you can trigger a send, but it's user enabled, right? It's not in the background.
Oh.
Same way you can do email. But even email, it will pop up a screen and actually show you the send screen from the email. And the end user has to hit send. So you don't have these applications in the background sending email or downloading people's contact databases and sending it to Russia or something. Yeah. Yes, any other questions? Okay, let's keep going, because how are we doing on time? I actually kind of lost track there. I better unload this, because I'm going to keep seeing this.
You sort of ran out of time.
Am I out of time?
Yeah.
Really? What am I doing? Okay, well, we're gonna go really quickly, I think. And we may skip some of these.
Will the agent be stopped when you uninstall a program?
So the question was, will the agent be stopped when you uninstall a program? And absolutely, it will be stopped and removed from memory, will disappear. It's part of the same package. So this is debugging. It's kind of important. I mentioned this earlier. You can change the period that you have to wait for that to happen. I set it to 15, which is whatever it happens to be. You don't want to be waiting 30 minutes between every test cycle. Let's see, debugging the agent code, it's pretty much the same as we saw earlier. You have access to the debugger when your foreground app has exited, because by definition the app is still running, right? You still want that access to that code, and you need to see what's going on. You need to be able to debug it, and so it's basically multi-process debugging. You have full access to that. And everything, the same thing that we did for a periodic agent works for a resource-intensive agent. It's exactly the same. What was that? Okay, we're going to skip that. It's pretty much showing debugging. Just trust me, it works exactly the same way we saw earlier. Another background transfer, another background type application, or multitasking type application, is file transfer. And essentially what it is it allows you to create a background task that transfers files to or from your application. The transfers continue to work even when even when the end user exits your foreground application. Basically, you're handing a location of a file in the cloud to a service and telling it where to put it, and it takes care of everything else. It's a hardened service. It takes care of multiple applications requesting files, and it takes care of making sure that it fires up the radio and is very efficient with using the radio, and doesn't allow too many files to transfer at the same time, so it doesn't affect the user experience. Yeah, so that's all you need to know. So you can fetch from HTTP or HTTPS hosts. FTP is currently not supported. Maybe we'll add that in the future, I don't know, but it's not currently supported. And the system pretty much maintains the queue, so you don't have any control over that. If you have multiple programs asking for multiple file requests, each one of them will get queued up. And your application can query to see how you're doing. So once you've fired a request, you can ask, what's going on? How far along are we? Are we complete? Did we error? You can check all of that stuff. There is a certain number of policies there. Maximum upload file is 5 megabytes, which is about the size of a photo. That's kind of the scenario we're trying to get to. Is there a question?
Yeah, can you make this type of check that we talked about?
Which kind of check?
Check how the download is.
So the question was, can I check in the background agent how the file downloads are going? And absolutely. Yeah, you can trigger a file transfer in the background agent. Yeah. Maximum file upload size is 5 megabytes. Over a cell network is 20 megabytes. Over Wi-Fi, it's 100 megabytes. And so if you have files that are bigger than that, then clearly you're going to have to chop them up so that you don't hog the queue with 3 gigabyte files that you're downloading VHDs to your phone or whatever. Yep.
Those limits are not imposed on the Mac application, so I can download other files at once.
Right, so the question was, well, what about a foreground application? Do I have a limit in the file size that I download in a foreground application? Absolutely, there's no limit. Because you're in the foreground, you have the CPU, you have the power, you can do anything you want. But if the end user hits that back button, you're gone. So you got to control that. That's the whole point of having background transfer. Yes?
You do like multiple file transfers, so essentially you can split a file into multiple pieces.
So the question was, can I do multiple file transfers? You can. You can split a file up into 5, 10, 15 pieces and download them one at a time in sequence and then reassemble them on the device. Yeah, in fact, that's what you would have to do, right? So there is some pretty good examples online. Basically, you want to check when your application is running in the foreground. You want to be able to check what's going on. So you enable an event handler, and that event handler for either status change or for progress change. And then you can do whatever happens, right? So if the file transfer downloaded a few bytes, you will get a progress change that says, hey, we've now moved from 10K to 12K download. Or if the file transfer completed, you would get a status change. We'll see how that works in a couple seconds, actually. So I've had problems with this app in the past, but let's give it a try. So someone said I'm already past time. Is that because we started lunch late?
It's you're 10 minutes past.
I'm 10 minutes over already?
Yeah.
From when I started, so I'm actually have been going for an hour and 10 minutes?
Yeah.
Holy smoke. Okay. Well, let's just take a quick look here. So here's how transfer happens. Find it. Here it is. So here I'm defining, I just don't have enough space on the screen. I'm defining my URI, I'm defining a background transfer request and telling it to transfer URI, telling it what kind of transfer to do, telling it where to transfer that file to, and then basically adding it to the queue, right? And then I have a message box that says, whoops, I caught an exception, whatever the exception might be, and I can catch multiple different kinds of exceptions. And then I'm also setting 2 event handlers, transfer progress changed, which is whenever, as you can imagine, whenever the progress has changed on the transfer, and status changed, again, when it's completed or error or what have you. And then if we look at those, so here's the status change, where it's going to get triggered on that transfer, and you can see, you know, if you check your status code is 200 or 206, that means it's completed, and then in this case we're going to display an image on the screen. Otherwise there was an error, and then at some point you want to take that transfer because it's completed. You want to take it out of the queue, otherwise it's going to stay in the queue, so you want to remove it. And then similarly on the transfer progress changed, there's just a text box that I'm updating with number of bytes received. I run this quickly. And hit start fetch. This wasn't working yesterday, but I was having network problems yesterday. And so we should see it start. Okay, well, I'm not going to wait for it just because. Okay. Well, we're going to stop there because I had one more that I wanted to show, which was notifications. So these are time-based on-phone notifications, which you can take advantage of. The same ones that are taken advantage of by the Windows Phone platform itself. So when you use the alarm system, for instance, this morning I set an alarm to get up so that I get here on time. That alarm system is actually using this notification service that actually pops up a sound and a window that says time to get up, right? Or I can use reminders, which are a little different, and I'll explain what the differences are in a couple seconds. These, as you can imagine, are persistent across reboots. So if I reboot, if I set a reminder for 3 weeks from now, I want to make sure that, you know, if the end user powers down and up again, that we don't lose that, and it's consistent with the phone UX. So the difference between alarms and reminders, alarms are pretty simple. You basically get a snooze and a dismiss, and that's it. If you click on here, nothing happens. They're modal, you only get one at a time, versus reminders, which give you a little bit more information, and you can also stack them, right? So in this case, I'm on number 204. If I swipe left or right, I can see the stack of reminders that are on the screen. And if I click on them, it will actually launch the app that triggered that reminder. So I can deep link into an app. Does that make sense? Okay, so here's how you set up a reminder, and an alarm is pretty much the same, except it has less information. So here it's saying when to begin, in other words, when to trigger. And right now it's saying date time now plus egg time, which is presumably defined up above. The content is your egg is ready. Recurrence interval being none. That means I only want it to happen once. I don't want it to happen every hour or every week or every month. And then something happens. If I click the navigation, I want something to happen. In this case, I want to go to the egg ready page.xaml. And that's it. And then once you've got all of this defined in your egg reminder, you basically add it to the queue, and it's just going to happen. So, and then at the end, once it's happened, you want to make sure that you remove it from the queue. Otherwise, it's going to be in there pretty much forever. So let's actually run one of these.
When the timer is started, how much time can you actually put of code in that small piece?
So the question is, when the timer is started, how much code can you put in here? The answer is none. There is no code running on timers or reminders. It's just a toast that comes up. And so there's no event or anything that gets triggered. So let me just run that. And so here, this is a pretty simple egg timer. I'm going to set it to 1 minute. I can do that. And if I start the timer and exit, if we wait a minute, and if there are questions in the meantime, because we're going to have to wait about a minute. Any questions? Come on, now you have no questions, right? You need a break. Yes, so do I.
It's a bit of off topic. Do you have access to the picture library?
So the question is, do you have access to the picture library? In what sense?
If you want to, let's say, transfer your pictures.
In alarms or reminders?
No, it's off topic. It's just have something to talk about.
Oh, okay, sure.
Yeah.
Yes, you do have access to pictures on the device or to trigger the camera. Yeah, so you have full access to all the photos in your media library on the device. Yeah. And the way you would do, there's different choosers or tasks to do that. And you could choose an image, and as part of that, you could say, allow the end user to choose an image or take a picture. And so here's my reminder that came up. I can snooze it or dismiss it. If I click on it, it will launch that app. Now you notice it launched the app, but it went not to the timer page, but to a separate page deep within the app. Okay, so I would show you the code, but actually we saw it in the thing. And so let me just spend 1 minute talking about audio playback agents. Like I said, not a lot of people use these, but the people who use them really, really need them. Essentially, it allows you to run playback of either local files or streamed files from the cloud. And as you do that, you're using the exact same infrastructure that our own media player on the device uses, including the universal volume control, skip, next, volume up, volume down. All of that stuff is fully accessible. The easiest way to do it, there's actually a Windows Phone audio playback agent right in the templates, so take advantage of that. It's the best way to learn. And there's also some good stuff online on, can you guess what the URL is for that? create.msdn.com, right. So we talked about some of this. The app provides either an URL or a stream to Zoom, which is the playback agent. And the audio will continue even if the foreground app is closed, because as you can imagine, it's actually running in the background. And the app is notified if a file or buffer is near completion, right? So as you're playing the file, you will get triggered and say, hey, I'm about to finish. Can you give me the next file so I can skip to the next file at the end of the current one? And then it's fully integrated into the Music and Video Hub, the Universal Volume Control, or UVC for short, with controls and contextual info. You can launch from the UVC, you can launch your app, and then, like I said, you get playback status, progress, metadata, all of that stuff is available. And so I think we're going to stop there. I am way, way, way over. Sorry about that.